Hey there! Have you ever wondered how attackers sneak into your cloud environment without even needing a password? Well, today, we're diving into one of the sneakiest methods hackers use to steal credentials: Cloud Metadata Attacks. Stick around, because by the end of this video, you'll know exactly how they work and how to defend against them. Welcome to Bluehat Cybersec Academy. Let's start by understanding what cloud metadata really is. Every cloud environment, whether it's AWS, Azure, or Google Cloud Platform, has something called metadata services. Think of these as internal APIs that your virtual machines or containers can access. They provide details like the instance ID, the region it's running in, its type, network configurations, and even service credentials or temporary access tokens. For example, in AWS, the metadata service is available at 169.254.169.254/latest/metadata. Applications running on an EC2 instance can use this service to grab temporary IAM role credentials to access other AWS services. This is incredibly convenient for developers because it eliminates the need to hardcode sensitive credentials. But as we'll see, this convenience also introduces significant risk. So, what exactly is a cloud metadata attack? Essentially, it happens when an attacker gains access to your instance and queries this metadata endpoint. They're after sensitive credentials, things like AWS IAM role tokens, Azure Managed Identity tokens, or GCP Service Account tokens. Once an attacker has these tokens, they can impersonate your instance or container, access cloud resources like S3 buckets, databases, and APIs, and even move laterally across your cloud environment. Put simply, it's like handing over the keys to your kingdom without asking for a password. Let me walk you through how these attacks actually work, step by step. First, attackers need to gain access to the target instance. They often exploit vulnerable web applications, misconfigured containers, or SSRF, which stands for Server-Side Request Forgery vulnerabilities. SSRF is particularly sneaky. For instance, if a web app fetches URLs based on user input without proper validation, an attacker could trick it into making requests to 169.254.169.254, your internal metadata endpoint. Next, once they're inside, the attacker queries the metadata API. A command appearing on the screen can reveal the IAM role name. Then, a second request retrieves temporary credentials also appearing on the screen. With these temporary tokens in hand, the attacker can now access cloud resources directly via APIs. Because these tokens are valid for only a limited time, the attack is stealthy and often goes completely unnoticed. To put this into perspective, let's look at some real-world examples. In the Capital One breach of 2019, attackers exploited a misconfigured web application firewall. This allowed them to perform SSRF attacks on AWS metadata endpoints and gain access to sensitive customer data. Another example comes from Kubernetes clusters. Researchers have shown that poorly secured Kubernetes services can allow containers to access metadata, which can lead to lateral movement across clusters. These incidents make one thing very clear: cloud metadata endpoints, while convenient, are extremely high-value targets. So how can we defend against these types of attacks? Well, defense requires a layered approach, combining secure coding practices, network controls, and strong identity management. First, minimize metadata exposure. Restrict access to metadata endpoints using firewall rules or security groups. On AWS, you can enable IMDSv2, which requires session-based tokens for metadata access. Second, secure your applications. Always validate and sanitize all user inputs to prevent SSRF attacks and avoid running untrusted code or privileged containers. Third, limit permissions. Follow the principle of least privilege by assigning only necessary permissions to roles or service accounts. Rotate and expire credentials frequently. And finally, monitor and audit. Log and alert on unusual access patterns to metadata endpoints. Use cloud-native security tools like AWS CloudTrail or GCP Cloud Audit Logs to track token usage. Implementing these steps will significantly reduce your attack surface and keep your cloud environment much safer. So, to wrap up, cloud metadata attacks exploit the very feature that makes cloud development convenient: the ability to programmatically retrieve credentials. By understanding how metadata endpoints work, and by applying strong security measures like IMDSv2, least privilege, and proper input validation, you can protect your cloud environment from these stealthy attacks. Now here's a little interactive challenge for you. First, if an attacker can access the metadata endpoint, what type of credentials are they trying to steal? Second, What cloud service feature can you enable on AWS to prevent SSRF from easily accessing metadata? And third, can you name one real-world breach where SSRF and metadata endpoints were exploited? Think about your answers. They're all right here in this video. Drop your responses in the comments. I'd love to see how you do. And if you found this video helpful, don't forget to like, share, and subscribe for more deep dives into cloud security. And for more content just like this, check out our cloud security playlist. Your next step toward becoming a cloud security pro starts there.